In section 4, we will look at quadratic equations and problem solving. Remember the general strategy for solving any problem. First, we want to understand the problem. That means possibly reading and rereading the problem, choosing a variable to represent the unknown, and if necessary, constructing a drawing. Second, we will translate the problem into an equation. Third, we will solve the equation, and last, we will interpret the result. Make sure your answer makes some sort of logical sense. The product of two consecutive positive integers is 132. We want to find the two integers. Remember that if we have two consecutive positive integers, we will always say the first integer is x. The second integer will be one more than that. If I start with 5, the next number will be 5 plus 1, or 6. If I started with 11, the next number would be 11 plus 1, or 12. So the second and the two consecutive integers will be x plus 1. Let's now go back to the problem and find the mathematical keywords that will help us set up our equation. So we start with product, two consecutive positive integers, and we've already defined those, is, and it's important to know 132. So starting with the product means multiply. So we multiply the two integers that we defined, x and x plus 1, and the product is, or equals, 132. So we start by distributing the x on the left-hand side to simplify the left-hand side. That gives us x squared plus x equals 132. Now, just like in the last section, we need to write this in standard form. So we subtract 132 from both sides of the equation. When we do so, we have x squared plus x minus 132 equals 0. Now that we have it in standard form, we need to factor the left-hand side. We start by looking for a greatest common factor, and there is none. We then look in front of x squared. The coefficient is 1, so we know that we can use two binomials, and each first term will be x, because x squared is x times x. We now look at the constant at the end and the coefficient of the middle term. We want two numbers that will multiply to give us negative 132, but will add to positive 1. Because the product is negative, one number will be positive, one number will be negative. Because the sum is positive, the larger number will be the positive number. When we look at the factors of negative 132, the factor pair that will satisfy both conditions at the same time is 11 and 12. The 12 is furthest from 0, so we'll keep the sign of the sum, which is positive. 11 will be negative. Negative 11 plus 12 is 1, so this is the factor pair we want. This factors into x minus 11, x plus 12, and we set this equal to 0 because we have to carry down both sides of the equation. At this point, we now want to set each factor equal to 0. Starting with the first factor, we have x minus 11 equals 0. We add 11 to both sides of the equation. And we're left with x equals 11. We do the same thing with the second factor, x plus 12 equals 0. We subtract 12 from each side, and we're left with x equals negative 12. For our answer, we have to go back to the problem and make sure both of our answers make sense. We were told that the product of two consecutive positive integers is 132. And so x equals negative 12 can't be a possible solution. So x equals 11 is the only possible solution. Plugging that into the two variables we defined, the first number, the first of our two consecutive positive integers, is 11, because it just is x. We had x and x plus 1. So x was just 11. X plus 1 will be 11 plus 1, which is 12. The two positive consecutive integers that multiply to 132 are 11 and 12. Let's try another example. The area of the parallelogram is 45 square miles. Find its base and height. And the parallelogram is shown. We're given two dimensions, the base, which is x plus 6, and the height, which is x minus 6. And it's nice that those are given because the area formula for a parallelogram is area equals base times height. So let's set up this equation. Area is 45, given to us in the problem, equals base, x plus 6, times height, x minus 6. So we start by foiling the binomials on the right-hand side. We draw our FOIL arrows, first, outer, inner, and last. That gives us 45 equals x squared minus 6x plus 6x minus 36. We combine like terms and they cancel. So we are left with 45 equals x squared minus 36. We then subtract 45 from each side of the equation, so we can have our equation in standard form. We're left with 0 equals x squared minus 81. Now, because we have two terms with a minus sign in between with no greatest common factor, the only possible factorization is a difference of squares factorization. So to do that, we need each term written as a number raised to the second power. This becomes 0 equals x squared minus 9 squared, because 9 times 9 is 81. To 0 equals, we have two binomials. X squared is x times x. 9 squared is 9 times 9. We add in the first binomial and subtract in the second binomial. So let's go to the next page and solve the equations. This page we had 0 equals x plus 9 times x minus 9. Using the zero factor property, we set each factor equal to 0. So we say x plus 9 equals 0. We subtract 9 from each side, and we're left with x equals negative 9. And x minus 9 equals 0. We add 9 to each side, and that leaves us with x equals 9. Now these are two possible solutions. They don't solve the original problem, which is finding the base and the height. Right away, we're going to cross out this x equals negative 9, and the reason why is because we cannot have a negative dimension. If we plug in negative 9 for either of our values, base or height, we'll get a negative value. And you can't have a negative base or a negative height while we're measuring. So the only possible solution is x equals 9. To find the base, we plug x equals 9 into x plus 6. So 9 plus 6, and that equals 15. To find the height, we plug our value into the expression x minus 6, or 9 minus 6, which is 3. Another example. An object is thrown upward from the top of a 112-foot building with an initial velocity of 96 feet per second. The height h of the object after t seconds is given by the quadratic equation h equals negative 16t squared plus 96t plus 112. When will the object hit the ground? This is probably the most important piece of the problem. When will it hit the ground? The height when something hits the ground is 0. So knowing that, we'll plug a 0 in for h. That gives us 0 equals negative 16t squared plus 96t plus 112. We have a quadratic equation in standard form. We need to factor the side that is not 0. So the first thing we try is to factor the greatest common factor. And after you take some time to do that, you'll find that the GCF is negative 16. So we have 0 equals negative 16, and we want to factor negative 16 from each term. When we do so, we will be left with t squared minus 6t minus 7. Now that we have factored the greatest common factor, we look at the resulting trinomial. The coefficient of our squared term is 1. So we can factor that trinomial into two binomials. T squared equals t times t. And we use the constant and the coefficient of the middle term to determine the other two factors, the other two terms. We want two numbers that multiply to give us negative 7, but that add to give us negative 6. As you go through that process, you will find 1 times negative 7 is negative 7, but 1 plus negative 7 is negative 6. So the two factors we want are 1 and negative 7. We use those to fill in the blanks in those binomials. Now once we've done so, we set each factor that contains a variable equal to 0. We ignore the negative 16 at this point because negative 16 can't equal 0. It makes no sense to even deal with that number at this point in time. So we set each factor that contains a variable equal to 0. That gives us t plus 1 equals 0. Subtract 1 from each side, and we're left with t equals negative 1. The second equation, t equals 7. Let's go through the process. T minus 7 equals 0. We add 7 to each side, and that will give us t equals 7. So the two possible answers are t equals -1 and t equals 7. So let's use the logic test again to see which answers make sense and which ones don't. T represents time. I've never seen a clock or a stopwatch that records negative time, so it doesn't make sense to have a negative answer when we're talking about time. The only good answer we have here is t equals 7. Problems we're going to use the Pythagorean theorem, or we will need to use the Pythagorean theorem in order to solve. In a right triangle, we say the sum of the squares of the lengths of the two legs is equal to the square of the length of the hypotenuse. And so we would say the leg squared plus the other leg squared equals the hypotenuse squared. Another way you may have seen this before, a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. Examples using this theorem. Find the length of the shorter leg of a right triangle if the longer leg is 10 miles more than the shorter leg and the hypotenuse is 10 less than twice the shorter leg. And so let's say that the shorter leg is x. I'm going to draw a triangle. Let's just say the bottom side is the shorter leg, x. Now let's go back and look at the equation to figure out how we're going to set up the other two legs, or the other leg and the other hypotenuse. It says that the longer leg is 10 miles more than the shorter leg. More than means addition. So the longer leg is x plus 10, 10 more than the shorter leg. And the hypotenuse is, it says 10 miles less than twice the shorter leg. Remember, when we see less than, that's just like if we see subtracted from, we're going to reverse the order. So we start with twice the shorter leg, 2x, and then we subtract 10, so minus 10. We now have the three sides of our triangle. And once we have that, we now need to set up the equation. We take the leg squared plus the other leg squared equals the hypotenuse squared. Or we could say in this case, x squared plus x plus 10 squared equals 2x minus 10 squared. First, anytime I have a binomial squared, I'm going to rewrite that as two binomials. So this becomes x squared plus x plus 10 times x plus 10 equals 2x minus 10 times 2x minus 10. Anytime we have a binomial times a binomial, we FOIL. So I'll write down x squared plus, we FOIL, and we multiply the two binomials. So we draw our FOIL arrows, and that gives us x squared plus 10x plus 10x plus 100 equals, we do the same thing on the other side. We're multiplying two binomials, so we need to FOIL. And that gives us 4x squared minus 20x minus 20x plus 100. At this point, we want to combine like terms on the left side and the right side. So I have x squared and x squared, which gives me 2x squared. 10x and 10x combine to make 20x, and also have 100. That simplifies the left-hand side. On the right-hand side, we have 4x squared. Negative 20x and negative 20x is negative 40x, and a positive 100. At this point, we will need to rewrite this in standard form. So let's go to the next slide and try that. X squared plus 20x plus 100 equals 4x squared minus 40x plus 100. We can move everything to the left side or the right side. I'm going to move everything to the right side. So I will subtract 2x squared, subtract 20x, and subtract 100. On the right side, we also subtract 2x squared, subtract 20x, and subtract 100. When we do so, everything cancels on the left side, giving us 0 equals. On the right side, 4x squared minus 2x squared is 2x squared. Negative 40x minus 20x is negative 60x. 100 minus 100 cancels. We now factor the right-hand side, the GCF, to 2x. We have 0 equals 2x times x minus 30. Now that we have two factors set equal to 0, we use the zero factor property. We set up our two equations, 2x equals 0, divide by 2, we get x equals 0. That's a possible solution. We then also set x minus 30 equal to 0. Add 30 to both sides. And we are left with x equals 30. So the two possible solutions here are x equals 0 and x equals 30. We were talking about the length of a leg of a triangle. It doesn't make sense for that length to be 0. We wouldn't have any sides if that was the case. So the only possible solution left is x equals 30. For example, where we will need to use the Pythagorean theorem. A ladder is leaning against a building so that the distance from the ground to the top of the ladder is 3 less than the length of the ladder. Find the length of the ladder if the distance from the bottom of the ladder to the building is 9 feet. So in the diagram, it gives us the length of the ladder is x. The height of the top of the ladder all the way down to the ground is x minus 3. And we're told in the problem that the distance from the bottom of the ladder to the building is 9 feet. So we have a triangle, a right triangle with all three sides given. Remember the Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared. So our legs in this problem are 9 and x minus 3. We plug in and that gives us 9 squared plus x minus 3 squared equals x squared. Now, just like in the last example, anytime I have a binomial squared, I write that twice. So 9 squared plus x minus 3 times x minus 3 equals x squared. Let's start simplifying. 9 squared is 81 plus, we need to FOIL where we are multiplying two binomials. And that will give us x squared minus 3x plus 9 equals x squared. We now combine like terms on the left-hand side. I have 81 and 9, which will give me 90. I have negative 3x and negative 3x is minus 6x. And we also have an x squared. And that is all set equal to x squared on the other side of the equation. Let's use the equation we have on the next slide to continue solving. If we rewrite the order, we can rewrite it as x squared minus 6x plus 90 equals x squared. Now let's move the x squared on the right side to the left side, just because we have more terms on the left side. On the left side, the x squareds cancel. On the right side, the x squareds cancel. We're left with negative 6x plus 90 equals x squared minus x squared was 0. So to solve in this case, we don't have an x squared, so we can solve like we did with equations in Module 2 and Module 3. We subtract 90 from each side. We're left with negative 6x equals negative 90. We then divide both sides by negative 6. And we're left with x equals 15. So the length of the ladder in this problem is 15 feet.